We're going to look at Unit 8.2 on pyramids. First thing that I want you to do on the pyramid to the right is I want you to label a couple points, a couple places on the pyramid. The first one, the top, sometimes that's referred to as the apex. Okay. Also, that square or rectangle on the bottom, that'll be what we use as the base figure when we do our formulas. So label those on your picture. The formula for volume, which is also be over on the sideboard, is 1/3 big BH. And we're going to look at the examples on the bottom of this page. So there's 4 that we're going to look at. The first one's a square pyramid. Now remember, when you're using the formula for a pyramid, we have that 1/3. We have our big B, or capital B, which means the base area. So this one's a square pyramid, so we're going to use the area of that square. And then the height is going to be connecting, in this case, that base figure to the apex. So that one's labeled as 10 centimeters. So when I take these values and put them into the formula, I end up getting 1/3. Then for the square, I have 8 times 8. And then for the height, we have 10. So I'm going to take the calculator. And I'm going to type that in the calculator. So I have 1 divided by 3, parentheses, 8 times 8 for my base figure, times 10. And we'll round the answer to the nearest tenth if we need to. So this volume will be 213.3 centimeters cubed. Moving over to the second one, pretty much the same thing we just did, except it's a rectangle, so we're going to use the same base formula. But again, you want to include that 1/3. And I have all the information I need. My base figure has measurements of 4 and 6, and then the height is 8. So I'm going to go back to the calculator, erase the work from 1 first, and I'm going to type in 1 divided by 3, parenthesis, 4 times 6 times 8, and then I got 64 centimeters cubed. Then we got, for 3, we have a triangular pyramid. So you'll see that base figure is a triangle, looks like a right triangle. I'm using the same formula again, because it is a pyramid. However, the big B will be different, our base figure area. So when I write this down, it's going to be 1/3. And then for the triangle, I have 1/2 times 5 times 3 for my area formula. And then I have a height of 8, so I'm going to multiply that by 8. So just like I did for the last one, I'll type that in the calculator. 1 divided by 3, parenthesis, 1/2 times 5 times 3, close parenthesis, times my height, which is 8. Which I end up getting a volume of 20 centimeters cubed. And then we'll move this down, we'll look at the last one. Now, we don't have the height in this question, but they give us what's called a slant height. So that slant height is located on one of the base figures going up towards the apex. But we don't have h yet. So we still need to figure out what our height is with our formula. Now I do have, and I'm going to highlight this, I have a right triangle, a two-dimensional right triangle inside the formula. And what I'm going to do, because we got a right triangle and we got two measurements trying to find the height, I'm going to use Pythagorean Theorem to help me get that height. So this x value here is going to be 3, which is half of the 6 for the measurement. So I got 3 squared plus my height, which I don't know, to one of the legs, and then 5 squared. So we end up with 9 and 25 when we square them. Subtract the 9 on both sides, we get 16, and then take the square root, and the height actually ends up being 4. Now I can use the formula, which would be 1/3. It's a square base, so it's 6 times 6 times 4. And then going back to the calculator again, 1/3 times 6 times 6 times 4 will give me the answer, 48 for the volume, and which is centimeters cubed. So just make sure you have all the measurements for the height of the pyramid along with the areas for the base figures.